let's remind ourselves about what we know about solving systems of two linear equations. So a linear equation is one that looks like, this equation or this equation. There can, when we have only two variables, there's call them x and y. There's a term where x shows up to the first power, and there's a term where y shows up to the first power, and there's a constant term, which might be 0. What makes this linear is that the variable terms, they only have the variables to the first power, and the variables show up in the numerator. They aren't multiplied by each other. That's what makes these linear. So it's variable times constants, right? Variable times constant, all added together. The coefficients in front might be negative, which is why it's okay to have a minus sign here. A system of equations is just more than one equation. And to solve a system of equations, remember what we're looking for is a single x value and a single y value that make both equations true when you plug them in. So it's not enough to find some x value and y value that works for the first equation and some different x and y value that work for the second equation. We want the same x and y values to work for both equations. So how can we solve a system of linear equations, two linear equations in two variables? Well, there's two main techniques. There's substitution and there's elimination. The idea with substitution is we could just take one of these equations and solve for x or y. You can actually take either equation and solve for any variable. In this case, I think it's going to be a little easier to solve the second equation for x. So let's move the y term to the other side. So that's going to give us minus 2x equals 5y minus 20. And then, divide by 2, minus 2, to get solve for x. We get minus 5 halves y plus 10. And then take this, we solved for one of the variables. So take that expression and put it into the other equation for the variable that you just solved for. So we get 4 times x, but x is minus 5 halves y plus 10 minus 5y equals 10. Okay, and now the resulting equation here only has a single variable in it, y, so we can solve for y. So multiply this out. Looks like we're going to get minus 10y plus 40 minus 5y equals 50. So minus 15y equals 10. Right? So y is minus 2/3. Okay? And I thought I worked this out to give me integers, so let me just double check. Well, one good way to double check is, well, we aren't finished solving this system yet, right? We have to find x and y. We don't have x yet, but remember we have this equation way back here, so we can take our y value, put it into there, and see what we get for x. So x equals minus 5 halves, and now we think that y is minus 2/3, except I have reason to believe that I've made a mistake somewhere, plus 10. So this is going to give me the minus signs cancel, the 2's cancel, we get 5/3 plus 10, which is going to be 35/3. Okay, so the x and y that we got are 35/3 and minus 2/3. Okay, so we can check if this is correct by plugging it into the original equations and just seeing if both equations become true. So if we plug this into the first equation, we get, remember our x value is first and our y value is second, we get 4 times 35/3 minus 5 times negative 2/3, and we have to check, is that equal to 10? Okay, well, let's see, we're going to get 140 thirds plus 10 thirds, is that equal to 10? Oh, this is thirds. So we're going to get 150 thirds. Is that equal to 10? Definitely not. So I definitely made a mistake somewhere. So where did I make the mistake? Let's see. This is okay. Dividing by -2. Oh, how'd this become 50 right here? This shouldn't be 50. This should be 10. And so this should be -30. And so this should be 2. Okay. All right, so now we can take our 2 and plug it into the equation to get x. So this should be a 2 right here. So we get 2 times, so -5, it's 5. So x should be 5. So what we should have gotten is 5 and 2. So let's check that. Put it into the first equation. 4 times 5 minus 5 times 2, is that equal to 10? So 20 minus 10, yes. And then the second equation, -2 times x, which is 5, minus 5 times y, which is 2. And yeah, that's -20. Okay, so that's one way to solve a system of linear equations. Another way to do it is using a technique called elimination. And often elimination is actually, for 2x2 examples like this with 2 variables and 2 equations, substitution works fine. But elimination actually tends to work a little bit better. So let's remind ourselves how that works. So 4x minus 5y equals 10, minus 2x minus 5y equals -20. Okay, so the idea with elimination is, with these 2 equations, we can actually replace an equation with a multiple of itself, and we can also replace either equation with the sum of the 2 equations. And it turns out that that won't change the solutions to the equation. And that lets us sort of get away with a nice trick. So what we're going to do is arrange for one of the variables to cancel when we add the 2 equations together. Currently, when we add the 2 equations together, none of the variables cancel, so we're not ready to add the variables together yet. But remember, we can replace any equation with a multiple of itself. In particular, it looks like if we multiplied the second equation by -1, we'd have plus 5y, and then when we added the negative 5y, the y's would cancel. So let's take the negative of equation 2. That makes the system 4x minus 5y equals 10, and 2x plus 5y equals 20. And now we can add the 2 equations. We're going to get, let's see, for our x's. So when I say add the equations, what I mean is we're going to add the left-hand sides and add the right-hand sides. So on the left, we get 4x plus 2x is 6x. And then negative 5y plus 5y, that's 0 times y, right? So there aren't any y's left. And then on the right-hand side is 30. And now we can divide by 6, and x is 5, right? That's looking good because, right, we know that x is supposed to be 5. Now that we know one of the variables, we need to go back and find the other one. And we can choose either equation here, right? Actually, any of these equations would work, right? Any equation that has an x in it and also a y, we can use to turn this x value into a y value. So let's use, I don't know, how about this one right here? So 2 times 5, which is x, plus 5 times y equals 20. So this is 10, so subtract 10 from both sides, we get 5y equals 10. And that means y is 2, and we get that x comma y is 5 comma 2. So you can see no matter which method of solving you use, substitution or elimination, you will get the same result if there is a solution. Remember, some systems of 2 linear equations don't have any solutions, and some have infinitely many solutions. But if there is just one solution, either method will get you to that solution.